Well, first of all, GaN is a very important technology going forward. We believe we will be using GaN extensively in our new products. In fact, almost all of our new products already have GaN going into them. And the reason is GaN is a much higher efficiency and much higher frequency technology, which means you can make power supplies smaller, lighter, and more efficient. So we think the future of GaN is very bright, and we are certainly very much a part of that. When we started out with GaN, we thought the markets that would be most interested are the ones that want much smaller and lighter power supplies. The obvious one is the adapter for cell phone chargers. They have to be lighter and they have to be small. And the power levels in this market is going up dramatically thanks to fast charging and also 5G. And people don't want to carry large adapters. But interestingly enough, obviously that has been our first market. We are growing very rapidly there. But interestingly enough, we are finding that many other markets like GaN for different reasons. For example, our first design win, believe it or not, was a TV market where the efficiency of the GaN was very important to them. TVs have efficiency regulations, so having a more efficient power supply allows them to meet those regulations. The other market, which is quite surprising to us, is the appliance market. You would think in an appliance, you wouldn't care about size. Certainly, if it is a dishwasher, washing machine, or refrigerator, who cares about the size? We have a lot of room there. But it turns out that they do care about two other aspects of GaN. One is the ability to eliminate heat sinks. And heat sink is a huge reliability problem for appliances. When the appliances are transported, they go through vibration where sometimes the heat sink falls off, or they can actually break off the board, which is a reliability problem. And so they really like eliminating heat sinks. So that's one. The second one is efficiency. Many of these appliances have to meet very strict efficiency rules, and they are able to meet this efficiency by going to more efficient power supplies, in addition to many other things. A lot of people are concerned whether the technology, the GaN technology, is robust enough to be used in very high voltage applications, or in applications where there is high transients, I should say. Like in India, like in other countries where you have unstable mains voltages. But it turns out that our GaN technology is actually very robust for multiple reasons. We have a much higher voltage than most other GaN technologies available. We rate it at 750 volts for transients. Most others rate it for 600 volts or 650 volts. And it also happens that the GaN doesn't have a very sharp breakdown like, for example, silicon does. So it's able to withstand short-term transients very well compared to silicon devices. And we are finding that in real-world applications, GaN is actually more robust than silicon, which would probably surprise a lot of our viewers. We have developed a very unique technology that is specifically suited for what we do, which is we provide a system-level solution which is specifically targeted to power supplies. Whereas most other companies offer discrete devices which can be used in any application you want. So you never know what application it goes into and who is driving it, which controller is driving it. So it makes it really difficult for customers to use GaN because it is so fast that many customers, when they try to drive it, it causes oscillations, it causes very high frequency noises for EMI, makes it very difficult to use. The second advantage we have is that we provide a fully integrated solution where the GaN switch is combined with the controller in the same package. Now, if you do that, you have a fantastic advantage. And the reason is you know exactly what switch you're driving in each and every device, and therefore you can tailor the driver to optimally drive that GaN so that you not only have a very high efficiency, but you also don't have any oscillation problems when you switch, and also you don't generate too much EMI. In addition to that, you can protect the transistor a lot better because the proximity takes care of a lot of parasitics you would have with a discrete device. and therefore we can turn the transistor off very quickly. There is another technology we have that helps us do that very effectively. That is, we have lossless current limiting. The lossless current limiting allows us to not only sense the current without any losses, but it also allows us to turn off the device very fast. The alternate technology which discrete solutions use is an external resistor. In many cases, that resistor can be actually higher resistance than the resistance of the switch, on resistance of the switch. And the reason they need a high resistor value is to be able to get enough signal to be able to turn off the switch fast enough to protect the transistor. We don't have that problem. We actually use, in many cases, either the on resistance of the switch itself as a sense resistor, or we use a sense FET. In either case, there is no loss, and it is incredibly fast. So we can guarantee to our customers that our solution will not only be more efficient, it will be easy to use because there is no EMI issues to worry about, there is no oscillations to worry about, but it's also fully protected under all fault conditions. It is very different from other people's GaN, and we have taken I've gone to extreme lengths to make sure that this GaN is very, very robust and very, very reliable and easy to use.